0. Ok, da er vi tilbake i studio etter å ha sett denne videoen fra DJIs hovedkvarter i Kina. DJI er jo et navn som vi stadig hører, fordi det er jo den mest dominerende droneprodusenten for vanlige droner, for hobbydroner, men den er også en viktig aktør i markedet for kommersielle droner. Og med oss i studio nå så har vi Felix Tian, som er director for Enterprise Solutions hos DJI. Welcome, Mr. Tian. You are working with the development of enterprise solutions for the drones, DJI drones. What can you tell us about the latest development in this area?
Right. I'm more responsible for the software solutions for our enterprise drones, specifically our new software called DJI Terra, which is mainly a photogrammetry software, where we updated, brought up the latest version in September at Intergeo in Stuttgart, Germany, and we keep bringing out more features and updates throughout the time, and there are definitely more exciting things coming out next year as well. Yeah.
So that means that, for instance, the Mavic Enterprise can be equipped with different with cameras that you already have today, and with the new software, these drones can do many more new things.
Yes. This software, the DJI Terra, is deeply integrated with our Phantom series, actually, including the new Phantom 4 RTK, the Phantom 4 multispectral, but it also can process the photos collected by other DJI drones, like the Mavics or the Inspires. It's just with the Phantoms, especially the RTK and the multispectral, we have features like real-time mapping and more accurate accuracy and precision guaranteed. But yeah, with different payloads, different flying platforms, it can do different things.
Yeah. You have a presentation you can show a part of us for us.
Yes.
If you can get that on screen, yeah.
Right. So here's a brief presentation about DJI Terra, what it is and what it can do. So if you can go to the next slide, maybe the next one as well. So you can see this is a basic workflow that we integrated into Terra. It starts, instead of just photogrammetry, it starts all the way from mission planning to data collecting to processing and to analysis as well. Next slide. Next slide. And in order to produce a good quality, high resolution accuracy result, we also included several kind of templates to help the users have a lower entry barrier to use the software. Next slide. Next one. And this is a interesting way of planning your mission. So in the background is actually a 3D model representation of a simulated crash site of a truck and a car. And in order to plan the mission, you can actually plan it on the 3D model by selecting whatever the point or the waypoint it should be. And then in the right corner, bottom right corner, you can see a virtual camera view of exactly what the camera will see at that point. So it's a more intuitive way of helping you to plan your flight mission. Next one. Yeah, this is also a video showing the process. Next one. And of course, we have more traditional way of just selecting the area, and all the parameters will be preset. And then from there, all the route will be automatically generated, and just one click of a button, mission will be uploaded, and everything else is all automatic. Next slide. I'll just skip some of the technical details and let's go to some of the real use cases that we have. Next one. Yeah, keep going. Keep going. Sorry, there are so many, too many slides. Yeah, next one. Yeah, well, this is a new mode that we call the corridor type mission, whereby just importing the direction of a river or a railway or a highway in a corridor shape, the mission will also be automatically generated. Next one. In this way, like it's guaranteed by using this template, all the settings, you will be able to collect the data in the right way and generate the result that you want. Next one. Next one. Next one. So this is quite special about Terra is because we also manufacture the drones and the cameras. So we introduced this we call it the real-time reconstruction. This is in 2D. So in this case, especially for those time-sensitive missions like search and rescue, firefighting, you can actually have a 2D ortho map in real time on the site in the field, and which is very critical to the search and rescue teams, the firefighters and police officers, which in the past it take, let's say, like a half an hour to collect the data, an hour and a half to process the data. But in this case, everything is in real time. All right, next one. And this is where a real case where one of the insurance companies used Terra, the real-time mapping feature, last year when a severe typhoon hit the southern part of China. So they need to quickly map the area and measure the size of the forest that's being damaged and generate a report for insurance purposes. And you can see there's also this pause and continue feature where if you're out of battery, it will remember where it stopped, and then you can change the battery and it will continue the mission. Yeah. All right, next one. And what's more exciting is besides real-time 2D, we also introduced real-time 3D reconstruction in September this year. So we added another dimension to the result that you can get in real time at the site. Next one. Next one. So these, also the next several pages, are all screenshots of different scenes being 3D reconstructed in real time. So this is kind of a factory environment. Next one. Kind of a bridge in the mountain. Next one. City environment. Next one. Yeah, so these are all, again, generated in 3D and with colored point clouds. Next one. Next one. And instead of besides the real-time one, we also, of course, have the more traditional post-processing reconstruction where you have higher resolution, higher accuracy. It takes more time. But again, we also emphasize on the efficiency. It takes more time comparing to the real-time processing, but again, it's still super fast if you try it out and compare it with other solutions. Next one. Next one. Next one. This is a case where we covered approximately around 6 kilometers squared of an area by taking over, I think, 5,000 photos. Next one. Next one. This is the result that you can get, and you can find out how much detail you can get. Next one. Zoom in again. Again. Yep.
Wow.
Next one. Some other angles. Keep going. Yep. Next one. Next one. Yeah. So you can see a lot of comparing to like let's say, satellites or airplanes, drones definitely have the advantage of being able to collect a super high resolution image. And with Terra, you can process those images extremely fast with very high accuracy.
Yeah.
All right. Next one. Keep going. Oh. So this is the multispectral images that we collect, and then using Terra, we can generate the different vegetation indices for precision agriculture as well. Next one, please. Next one. So this is very exciting, and I want to point out that so at DJI or for the Terra team, we work very closely with a lot of the enterprise customers, the leaders in the industries, to help them solve some of the very difficult corner cases where they want to reconstruct tiny details. For example, on the telecommunication tower that you see on the right. And if you see the next page, next one. So this is an original photo shot using a Phantom 4 RTK, and the next one is a 3D model being reconstructed. The first time I saw it, I thought it's a Photoshop, and then you take the background away. Yeah. But if you see the next one, when we turn off the colors or the texture, and when you see the mesh, then you can still see all the details of the wires, the antennas, and every single detail of the tower. All right, next one. Yeah, keep going for probably 5 to 6 pages. So this is where we work closely with one of the telecommunication inspection service provider in the States. And they helped us collected a lot of data, and we helped them improve the algorithm. And in the end, everyone is happy. All right, keep going. And some more, like, I think if you're familiar with photogrammetry, then you must know that the most difficult part of image-based or vision-based photogrammetry is to reconstruct all those tiny little details. But luckily we're able to do that using Terra. Next one. And this is a case where we use it for heritage site protection, and you can see how much detail it can generate, and to help the researchers to do their work. Next one. Next one. Next one, please. And this is a case where this is the latest airport, or probably the biggest airport in China that has just been opened last month, I think, in Beijing. It's called the Daxing International Airport. And we got an opportunity, this great opportunity to 3D, because you guys must know it's extremely hard and it's probably impossible to fly at airports. But this is like 3 hours before it went into so we got this super precious opportunity to bring this to the airport for further practices and analysis of the buildings. Yeah. The next one. Next one, please. And this is another example that we helped for heritage site protection. And this is a hanging temple, a very famous one in China, which was built like hundreds of years ago on a cliff. And just imagine buildings, structures like this, if anything happens to it, it's impossible to rebuild it if you don't have a digital or design with you. But in the past, like, it's quite impossible to do it. And if you think of the unfortunate tragic happened earlier to the Notre Dame, actually we also did a similar thing to it after the accident, but we are not allowed to share the data yet to the public, unfortunately.
Yeah.
Next one. Next one. And these are maybe you can keep going. So these are actually screenshots of the 3D models, not photos. But if I tell you they're actually original photos, you'll probably believe it's photos, right? So the much of detail that we can achieve, it's quite incredible. And this is actually the buildings you see in this video is actually the new headquarter buildings of DJI. Being under construction in Shenzhen, China. It's a twin tower building, and hopefully we can finish it within another 2 years. But we started this kind of a track, like a 3D reconstruction of the whole site from the very beginning, where there was nothing, and it helps because we saw a great potential in the construction industry or the AEC industry, and we want to use our own project as a test to try everything out. All right, next one. Next one. And this is one more thing, that example that shows that by working very closely with the industry, that we can achieve something really amazing. So this is with the power line inspection. And we work with one of the biggest power line company in China, the Southern Grid. Actually, we've brought several of our power line companies in the Nordics, the Vattenfall and the one in Norway, to Southern Grid to kind of communicate with each other, share the experience. So by working with Southern Grid, we've actually tested the data for over 10,000 kilometers of power lines. And next slide. And you can see all the lines and the details of the towers are still there, just using photogrammetry. Because in the past, you would need a helicopter with a super expensive LiDAR system to achieve this kind of detail and accuracy. But now with this solution, it's more cost-effective and less risky. Yeah. Next one. Next one, please. Yeah, it's just some more examples. And it's for this kind of a low voltage power line, it's more dangerous if you want to use a helicopter to do the scan, because you have to fly really low and change directions all the time. But with a multi rotor like a DJI Phantom RTK or Phantom 4 drone, it's much easier to do it. Next one. Next one, please. Yeah, so we've seen quite a lot of examples that how people are using DJI Terra and the Phantom drones to do mapping, and I just want to say that it's a technology that we want to introduce to different industries, to empower different industry and bring the true value of the data to different workflows. And after that, you can do different kind of analysis, machine learning, or detection on top of the 3D and 2D original photos. Yeah.
Thank you very much. I'm impressed with what I'm seeing here, and this shows just a truly possibility which lies in drones.